among the most visited monuments in the world. The city of Venice is the third city in Italy for air traffic. And recently, the city has introduced limitations to the number of tourists that can reach the city. Just to give you an idea of how big and how important it is for Italian tourism, these landmarks. It's not just important for the Italian tourism, it's also important for the economic of the economics of the city of on the region of Veneto. In fact, Venice is also the capital of Veneto region, and therefore is also an important administrative center with universities, with political palace, and therefore when the flooding events happen, you basically stop also the administrative life of the city. Of course, there is also another point to address when we talk about impacts of climate change on this coastal city. It's not just about the cultural heritage, but the cultural heritage is also just the heritage of people. We've seen this also in France with after the destruction by the fire of Notre Dame de Paris. The value of the cathedral after the fire basically rised because of all the investment that had been done to restore the cathedral the way it was before. So it may happen also that when something is destroyed by an unfortunate event like a fire or the Acqua Alta, then there is also some attachment from the population and some need to get it restored even beyond its actual cost. So that's why it's important to evaluate how the city can respond to the flooding events, and also whether the strategies that have been set by the Italian government are effective in protecting the city. So, in fact, let's go more into the detail on how the Italian government has protected Venice. They built a barrier that is called MOSE. So it's an experimental electromechanical module that is basically a moving barrier that can raise or be lower when there is the need. So normally the barrier is not active and allows the waters to enter in the Venice Lagoon. So you can see here in the figure, in the picture from the satellite, the structure of Venice Lagoon. Here is the city of Venice, where I'm pointing now. And then there are 3 entrances in the lagoon. These entrances is where the barriers are placed and then can be activated. When they are activated, basically the water level can be low inside the lagoon and instead can be higher outside. So it's this mobile system is very costly, and the cost is about 6 billion euros. And the MOSE system started service in 2020, so it's a really brand new structure, and it has been already activated over 40 times. This number is already higher than 43 because this autumn and winter it has been activated even more. And the activation cost of the barrier, every time that the Italian government and the Venice authority decide to activate, it's about 250,000 euros. So it's kind of a costly measure to protect the city. So now we have to understand what are the kind of events that can produce the flooding in the city of Venice. So the impacts, of course, is what I was describing. I was detailed just to make you understand that this is a challenge that is not only related to the city of Venice, but coastal cities are really experiencing flooding events that are becoming more frequent because of climate change, because we have the sea level rise, but also they can be enhanced by climatic hazards such as wind and rain. And for the city of Venice, we know what is the event that triggers this Acqua Alta, and in fact, these events are Mediterranean cyclones. So we want to evaluate how the climate variability, the greenhouse gases emission, concur to producing this climatic hazard, and of course go down to the level of the impact. So you see here that when we will try to do this procedure, we are not doing the typical procedure of the statistical attribution, which focus on the at the level of the climatic hazard, so wind, rain, or sea level rise, but we are doing a step backward or forward, if you like meteorology as I do, in the sense that we look at the causes of compound climatic hazard that are at a certain at the scale of the city, that are wind, rain, and sea level rise. So this causes is the presence of a Mediterranean cyclone. So as you can see, the way it will we will work is to identify, for example, for the event that I was showing at the beginning of the presentation, that is the 4th of November 1966, the sea level pressure pattern that contains the Mediterranean cyclone that is affecting the city. So you can see here in this inset what happened. In fact, we have a low pressure structure over the Genoa law, and this Genoa law causes a cyclonic circulation, which sets the winds in an anti-clockwise direction. And so we have on the Adriatic Sea winds of Scirocco that blow from southeast into the sea and push the water towards the lagoon. They also produce this kind of configuration, also produce lots of rain in the Triveneto, so that is the Alps and the region that is north of Venice, and therefore we can have also a contribution to the water in sea level in the lagoon from the river. And the way we will proceed is to look at analogs of this sea level pressure pattern into two periods. One period that is the periods where the event actually happened for the 1966, that is 1950-1979, is the beginning of the dataset that we use, that is the Copernicus Era 5 reanalysis. And then we will look at the analogs in the 1992-2022 period and see if there are changes, taking present minus past analogs and performing some analysis of the statistical significances of the differences. I will go into the details of this and I will again recap the procedure. So we use the ERA 5 data in the period 1950-2022. The event in the attribution sense is defined as a specific combination of patterns that here are sea level pressure, precipitation, and meridional winds in a long latitude box around the city of Venice. And then we decide to split the dataset into two periods, considering that the 1993-2022 period is highly affected by climate change, and the 1950-1979 is barely affected by climate change. Then we will compute present versus past analogs and assess differences, significances, and the role of natural variability in the changes that we observe. So I will go to the results. So bear with me, because this is the most complicated slide of the presentation, but in fact it's quite simple. So we have a first column on the left-hand side that shows you the sea level pressure, the temperature, the precipitation, and the meridional wind for the event that we want to attribute, for which we want to consider changes. Then we have the average of the past analogs in the B column, the average of the present analogs in the C columns, and the changes in that is present minus past in the right-hand side, okay? So if we focus on the first line, we see the pressure, and we see the presence of the cyclonic structure with the minima over central Italy for the 4th November 1966 at midday. And then when we look at analogs in the past and in the present, we can see already that the analogs are not that good. But we can see that in the present, the analogs show deeper cyclones. And in fact, if we take a delta sea level pressure, we see that especially over the Tyrrhenian Sea, we have a lower pressure. This lower pressure contribute to no changes in temperature, but it increases the precipitation over the mountains of the Alps of Veneto and also the Apennines in Emilia. And it also produces more winds on the Adriatic and on the Pianura Padana, the Po Valley, more meridional winds that then contribute to intensify the Acqua Alta events. So this is for the 1966. We can also evaluate how exceptional was the event of the 1966 with respect to the events that we have already in the database. And to do this, we can devise a metric of quality of the analogs. So this quality is the black dot in these violin plots is the distance of the event, so the 1966 from the analogs compared to the distance of the analogs from their analogs. So it is the blue violin plots in the past period, and the red is the distance of the event from the closest analogs in the present. And then we compare this to the analogs of the Mediterranean cyclones that we find in the present with respect to their analogs. So this shows, in fact, the exceptionality of the event, and that basically the analysis that we are doing is with events that are similar in the structure, but in fact not as deep as the cyclone that happened in 1966. Then we can also see that the p-values here refers to the Kramer-for-Mises test that tell us if this distribution, the past and the present analogs, is statistically significantly different. And in fact, it is, because we have a p-value of 0.04. And as you can see, the quality, so the black dots approach somehow the red distributions in more in the present period, although remain very far, which means that these events, the events that we see in the present period, are a bit similar to the one that we target. Then we also have a matrix of predictability and persistence to see if some properties of the dynamics change. And we see that we don't have a statistically significant signal in predictability or persistence, but it's interesting to note that that we have in the present time some cyclones that in hours is more persistent over central Italy and therefore can produce more winds blowing on that region for a longer time. It's just few events, but since we are doing extreme statistics, can be important. There is also a tendency in decreasing the analogs in October and having more analogs in November. And this is also interesting because in November we can have more rain and even sometimes stronger winds and stronger Scirocco winds, and also this can enhance the impact. So we can say, based on this analysis, the 1966 event has not repeated itself from the dynamical point of view. So the other step that we can do is to add to these schematics also the adaptation strategies. And this is something that we are doing, this procedure of evaluating also how the adaptation strategies can lower the impacts of the phenomena is something that we are trying to devise, some procedure that we are trying to devise, at least in a schematic and organized way, also with a colleague at IPSL, Aglaia Ezequiel, who is working at doing a framework where he can take into account this in adaptation strategies in a systematic way when we are doing attribution studies. And the idea is that we can construct words that are counterfactual, not only in the sense that is present and past, but also in the sense that we have done something to prevent the impacts of an extreme event. So here, for example, what we can do is, once we have the list of the analogs date for past and present period for the events that look like the 1966, we can use the measure in Punta della Salute, so in Venice, the city, and we can use the measure outside the city to compare the difference in sea level when the MOSE has been activated, if it has been activated during the analogs of the events. So to evaluate what would have happened without the MOSE, we can use this data outside the laguna, but we also need a damage model that tells us how big the loss in terms of economic damages could have been without the MOSE. And to do this, we have an exponential model that we have fitted. Tommaso actually has fitted to the data existing from the previous event. And as you can see, here is the walking level and the level of the San Mark Basilica's door. And you can see that if the water can reach the San Mark's Basilica's doors, then the damage can be very high and can exceed 100 million euros, and can also reach 1 billion euros if the events is the events of the 1966. And of course, we can also compute the damage, compute what happened. We can charge the cost of activation of the MOSE for a given analog date, that is 0.025 million euro. So now the way we proceed is the following. We have the present with MOSE is our factual words, okay? And we can see, we can draw the distribution of sea level for, in terms again of violin plots, for the past, for the present without MOSE, and for with MOSE, and for the present without MOSE. So as you can see, the event of the 1966 is the event that reached, sorry, basically the 200 centimeters. And then we have, of course, that the events in the present climate are higher than the event in the past climate because of the sea level rise, okay, that we take into account here. And we can see also that with MOSE, we have a tail of values that are below 100 centimeters, and this tells us that indeed for the analogs, for some dates that is analogs of the 1966, the MOSE has been already activated. So in fact, we can summarize the results in this table. We have that the MOSE has been activated already in 11 dates that are analogs of the 1966, that is the 40% in the present period. And we can see that if we compare the values in centimeter of the sea level, that was 194 for the event, in 1950-1979, so without MOSE, we were having a median value of 122 with, let's say, quantiles that are for the 5th percentile, if we want, 116 and 189. It is lower with the MOSE, that is 111, and much lower values for the 5th percentile. And in fact, it's higher without MOSE. So the upper bound is still 156 because we didn't record events that are as strong as the 1966, as we were saying. And we can see that still we have many events that are above 100 meters, which are already events that can damage the city. And talking about the damage, the damage that we experience now is 0.09 million euros. And in the past, now due to the sea level, we still experience values that are higher, but thanks to the MOSE, we can reduce to the activation cost, basically. This is 0.25. Without the MOSE, we can have, on average, events that are more costly. But still, I want to remember that we didn't observe a real analog of the 1966, so the city is well protected against this event. It is activated when the events that look similar occur, and the assessment for this 1966 event is positive. But is this the end of the story? No, in fact, in the paper, we have analyzed different events that are the 4 major events that hit the city. And as you can see, we can have that for the events of the 1966, 2008, and 2019, the sea level reduction is significant with respect to this Kramer-Formiser test that we make between factual and counterfactual words. But for the 2018 events, this is not significant, and there are few activation of the MOS in terms of analogs. And what happened in 2018? Well, perhaps many of you remember that this 2018 event was not a normal extratropical cyclone, Mediterranean cyclone, reaching the city of Venice, but in fact it was a storm Vaya. And this storm Vaya was an explosive Mediterranean cyclone that was rapidly deepening over the Genoa Gulf, and for which, again, we find poor analogs, but for which we find also a strong signal of increase of wind, especially over the lagoon, and increase of precipitation. And we don't find really changes in terms of sea level pressure, because we have to look around the minimum, and around the minimum there are not many changes. So for this event, the city is not protected, and it's not well protected. And in fact, the problem of these events, as we have discussed with the city of Venice, is that in some sense they are quite new in the Mediterranean. They are these rapidly intensifying Mediterranean cyclones, and they are rapid. So in fact, the problem is that the MOSE is not activated fast enough to protect the city. So this is what we have given to the city of Venice as an output of this analysis. Of course, now with Erika and with the other colleagues in Italy and with Mireia, we are doing a step forward that is to see, using the analogs, what will happen in the future during this Mediterranean cyclone. And this study, of course, it has many limitations, because you have seen that the methodology is quite simple, that the damage model is extremely simple, and that the results also that we obtain are not conclusive for all the cases that we study, but still the framework that is basically finding an event, looking at the analogs in past and in the present, and for the present, seeing what would have happened without the adaptation measures that has been taken, could be a framework that is exported to other cities, for which either data of the adaptation measures that has been taken are available, or even models, statistical models or dynamical models of what would have happened without a certain adaptation measure could be devised. So this methodology can be used to study, for example, what happens with fires, what happens with heat waves, if there are data that then can support the impacts of the events that we want to study. And I want to finish with introducing more of these conditional attribution of extreme events to some atmospheric circulation. This is the Climameter, is this framework that we have launched together with colleagues from XAIDA and other colleagues all over the world, and where we are covering now over 30 extreme events that happened in the last years in an almost real-time manner. And as you can see, if you go on the website, perhaps I can go, you will find the same kind of analysis based on analogs and the last events. Okay, so I have to update the blog. Let's see. I don't want to pay. Okay, so I will just deactivate this. Sorry about that. In fact, I don't even have advertise on my website. So let's see. Okay, so if we go here and we look at the last events that we have covered, this is the blizzard that occurred last week in the United States. And the idea is always the same. We target the surface pressure pattern and we look at changes in factual minus counterfactual periods. In fact, I can show you the complete output of the analysis. So this will be the pattern that we target. These are the analogs for the past, the analogs for the present, and the changes. And then what we diagnose is how these changes affect temperature. So you can see that that was a winter storm in the US last week and caused basically the disruption of transportation. Can happen with still the same kind of temperature. We don't have a strong signal of temperature in central United States. But what is interesting is that it increased the precipitation over all this area that goes from Louisiana to the eastern coast of US and also in the western coast of US, and therefore can still produce more snowfall and also stronger winds over the western coast with lower winds in the central part of the country. So you can see that then this is synthesized in the meters that are the basic of Climameter, and there is also an assessment on the way the natural variability affects the phenomena that has been done also for Venice, that concern the evaluating how the mode of variability of the ocean can influence, such as El Niño or the Atlantic multi-decadal oscillation of the Pacific decadal oscillation, can affect the event. In this case, they do little to the events. There is only one mode that affects the events, and then the quality of the analogs that we have discussed for the city of Venice give us also an idea of how unique is the event. So I invite you to navigate to the website through the event dashboard website, and you can find the events that we have covered so far that can divide by type, rain, cold, or wind, again, or heat wave. And of course, any feedback is welcome, also because we have for this Climameter a paper out in review in Weather and Climate Dynamics. Is an open access paper, so you can also give us feedback and comment there. And I will finish just by thanking you for your attention and by pointing out three papers that are related to this topic. One is, of course, the paper that has been published in NPG, Faranda et al. 2023. And then the paper with the methodology, that is this 2022 paper in Weather and Climate Dynamics, and another paper by Tommaso, which used the dynamical diagnostic of persistence and predictability to, again, evaluate the effectiveness of MOSE more in a weather forecast flavor. Thank you very much for your attention, and I'm happy to answer any question that you may have at this stage.
Thank you, David. So you're very welcome to ask other questions to David with I saw a lot of questions from Ted. If you want to ask them, Ted? You're welcome.
Hi, Ted.
Hi, Davide. Sorry, let me just get rid of my symbols here. Yeah, I was typing them in as I went along, so I don't know if you want to look at them.
Yeah, I've looked. I can answer if you want to look and ask them.
Well, I mean, I don't know if I have to ask them. People can read them. So I
Okay.
guess if you want to just,
Oops. Yeah, so we can go to your first question is about why there is no difference in the temperature. Yeah, so I think this is related to the fact that the analogs are more occurring in November than in October. Hi, Tim.
Okay.
So if there is a seasonal shift, then we can have this kind of effect. But sometimes it's also related. We also see it, Ted, with similar analogs in the similar season, in the similar months, but then it's the circulation. For example, imagine that you have, so I'm talking here about climameter or the events that we cover in climameter. Imagine that you have a stronger cyclone, okay, a cyclone that is deeper over a certain region, for example, on the Balkans. Then if the cyclone is deeper, then you can have colder air that is entrained by the Balkans, just because the cyclone is deeper. And so you will see some kind of dipolar structure in that case at larger scale, okay? So it might happen also that even with climate change, due to the dynamics, in some region you experience locally lower temperature, okay? And in some other area you will have higher temperature to compensate. So it's conditional, then it can happen.
But I guess, yeah, just to, I mean, because obviously when you do this with a modeling approach, it's a much more controlled situation, and you will always find warming, I think, because, it's conditional. So I guess because you're doing it statistically, there's different factors which you might regard as confounders if it's a seasonal cycle, for example, or some other, but it's a more complicated, you have more possibilities. Yeah, okay.
Yeah, that's it. Second question, the p-values is, so the null hypothesis here is that the distribution comes from, it's a Kramer-Formisen, so that we extract the values are from the same distribution. So the idea is that we can mix up factual and counterfactual, and there is no difference between the two. So when the level is below 0.05, we cannot reject the hypothesis that the distributions are different. Basically, that's the idea. And
well, I guess I was just wondering, maybe it's a bit of a technical question, but if you just have one null, you're saying that the distributions are different. So you do but is it a bit like a base factor? You're basically asking, because it's unlikely, if you just did a p-value of the dot compared to the distributions that you've got there, it's like just a single sample, it would be tiny because you're way out in the tail. So your 0.04 is actually
okay, no, I see your point. So the dot is left out from this analysis. So the black dot is an assessment of the of the two violin plots. Then for the dot, we have thresholds in the climameter. So if we are above the 99 percentile, then we say it's unique. If you are above, so I have to check exactly what are the way we define uniqueness in climameter, but there is some threshold that we fix, and is 99, 95, and 0.75, something like that. But the test is just between analogs of factuals and counterfactual periods, leaving aside the event itself. This is important.
Okay.
We can think, I don't know, if you have good ideas how to.
Well, I was just thinking, I mean, maybe because you could, as I said, since you have this mismatch with the dots here, but you basically could say, what's the likelihood of seeing the dots under the past or the present distributions? And they may both be very small, but the Bayes factor is just a ratio of the p-values, and that's something a little more sensible. So it's sort of how unprecedented it was so it's a little bit of a different it brings in the comparison with the event though. Directly, I don't know. That's just another way of looking at it.
Can definitely, we can definitely think about it. Thanks a lot for this suggestion. Then for the violin, this is also, interesting. Yeah, there are two things actually. One is the fact that, here the representation of it's a density function fit. So this looks wider, but actually there are a few points that are where here the present with Mose is higher than this without Mose. Why is that? It's that because we have two different stations that measure. One is in the Laguna and one is outside the Laguna. So here we are saying that this yellow is good proxy for what happens in the Laguna without Mose, but for some of the events we have the two measure without Mose because the Mose is not activated. One inside and one outside. And the one inside is slightly higher because the water is pushed more towards the city.
Yeah. But
Okay?
isn't it also that I guess the integral, the area within the curve is different in the three plots.
Yeah.
But if you
Yeah.
normalized it, to have a unit area, then it would require to shrink
To shrink the distribution. Yeah,
and
there
then it
is
would be
this, but there is one value that is higher in this one than in this because the stations are different.
Okay.
Yeah, so thanks also for this. And climate meter in the global south. Yeah, because we start to cover. So the question is, what is the reason? What is the reason why climate meter has so few events in the global south? The reason is that we are starting to cover more the mid latitudes, the region where we know how the weather is evolving, and we are more expert on this. And now we have new scientists who join climate meter from Asia and from South Africa, and we will also scientists joining from Australia, and we are looking for scientists in South America. And that would be very good because the idea is that we will cover more events, of course, in the global south. We will have the cyclone Belal, the cyclone which affected La Réunion out at the end of the week. So we're doing the best, but of course we can do more on that.
So I guess what was behind the question. So it's based on the expert judgment that you need, not necessarily anything inherent.
No, to the methodology.
But I wonder whether, the ability to find analogs is somehow, I guess it'll depend on the system, won't it? Yeah. Thank you.
Thank you very much, Ted.
Anyone has a question want to raise a point with Davide?
Just, I want to stress again that this is a sort of prototype study. So it's really first idea on how we can use this conditional attribution to study the impact. So what you highlighted, Ted, of course, is are very interesting discussion points. We can do better both from the statistical point of view and from the dynamical point of view. So the next target is the Bologna floods, the Emilia-Romagna floods of the last year. And we are doing this also with some of the people that are in the list of authors for this paper.
Okay, well, unless there is a last question, I suggest let's finish there.
Thank you very much. Bye.
Bye, everyone. Thank you.